The universe is everything. It includes all of space and all the matter and energy that space contains. It even includes time itself, and of course, it includes you. Earth and the moon are part of the universe, as are the other planets and their many dozens of moons. Along with asteroids and comets, the planets orbit the sun. The sun is one among hundreds of billions of stars in the Milky Way galaxy, and most of those stars have their own planets, known as exoplanets. The Milky Way is but one of billions of galaxies in the observable universe. All of them, including our own, are thought to have supermassive black holes at their centers. All the stars in all the galaxies and all the other stuff that astronomers can't even observe are all part of the universe. It is simply everything. Though the universe may seem like a strange place, it's not a distant one. Right now, wherever you are, outer space is just 62 miles away, only 100 kilometers. Whether it's day or night, whether you're tucked indoors, walking beneath the sky, drifting to sleep, or quietly sitting in a classroom, outer space is just above you, so close. And it's below you too, about 8,000 miles, 12,800 kilometers. Straight down, on the far side of our planet, waits the quiet, endless vacuum and the soft hum of radiation in the stillness of space. How old is the universe? The universe, as we understand it, appears to be about 13.88 billion years old. Scientists reached this number not by guessing, but by listening to the cosmos itself. They measured the ages of the oldest stars, traced the quiet rhythm of cosmic expansion, and watched the light of galaxies stretch and shift through space. Almost every galaxy is drifting away. Not just from us, but from each other. The farther they are, the faster they flee. We might expect gravity to slow them down, but instead, they're accelerating, slipping away into the unknown. No one truly knows why. In the distant future, these galaxies will be so far, their light won't reach us. The night sky will grow dimmer, quieter, lonelier. To put it another way, everything, matter, energy, even space itself, was more compact last Saturday than it is today. And the same is true of any moment before. Last year, 1,000,000 years ago, 1,000,000,000. But the past, it doesn't stretch on forever. By measuring how fast galaxies move and how far they've gone, scientists have turned the universe into a kind of clock. Go back far enough, and you find a time before stars, before galaxies, before atoms could form, when heat and density were so immense that photons had nowhere to travel. Back even further, and all of it, space, matter, energy, was in the same spot. Not inside a place, but as the place itself. Don't picture a dark space where an explosion happened. There was no space, no time, no before. The Big Bang wasn't in the universe. It was the beginning of the universe. Time itself bloomed with it. From a single, unfathomably small point, space began to stretch and stretch, unfolding into the vastness we see today. The universe contains all the energy and matter that exists. Much of the observable matter takes the form of individual atoms of hydrogen, the simplest atomic element made of only a proton and an electron. When two or more atoms share electrons, they become a molecule. Trillions of atoms clumped together, that forms a dust particle. Smoosh a few tons of carbon, silica, oxygen, ice, and trace metals, and you get an asteroid. Gather 333,000 Earth masses worth of hydrogen and helium, and you ignite a sun-like star. For simplicity, humans categorize clumps of matter by their attributes: galaxies, star clusters, planets, dwarf planets, rogue planets, moons, rings, ringlets, comets, meteorites. Each is just a collection of matter, behaving differently, yet all governed by the same natural laws. Scientists have tried to count these clumps, and the numbers are staggering. The Milky Way alone holds at least 100 billion stars, and the observable universe, at least 100 billion galaxies. If galaxies were uniform in size, that would mean 10,000 billion, 10 sextillion stars light up the cosmos. But not everything can be seen. There's a vast amount of matter and energy we can't directly detect. All the stars, planets, black holes make up less than 5% of the universe. Roughly 27% is something we call dark matter, and 68% is dark energy. We don't understand them, not really. We call them dark, not because they're evil, but because they're hidden, silent, just beyond our reach. Yet without them, the universe wouldn't work the way it does, not even close. Our planet Earth is an oasis, not only in space, but in time. It may feel permanent, unmoving, eternal, but the truth is, Earth is a fleeting presence in the vast lifespan of the universe. For nearly 2/3 of the time since the universe began, Earth did not even exist, and in its current form, it will not last forever. Several billion years from now, the sun will begin to swell, expanding outward, engulfing Mercury. then Venus, and one day it will fill Earth's sky with fire. It may even grow large enough to consume our world entirely. It's hard to know for sure. After all, we've only just begun to decipher the cosmos. While the distant future is difficult to accurately predict, the distant past is just a little less mysterious. By studying the decay of radioactive isotopes found deep within Earth and scattered through ancient asteroids, scientists have uncovered a story written in atoms, a story that tells us our planet and this solar system we call home formed around 4.6 billion years ago. Human understanding on what the universe is and how it works has changed over the ages. For countless centuries, mankind had little or no means of understanding the universe. Back then, they all relied on myth to understand the origin of the universe. And several centuries ago, mankind then began to use mathematical calculations in order to find the hidden secrets behind the origin of universe. And with the time, these methods refined, and so does the scientific tools, revealing small hints about the origin of the universe. And since then, our knowledge about the universe has only leapt forward. Only a century ago, the astronomers succeeded in seeing the farther galaxies. And only a half century ago, mankind sent probes and man-made satellites to space. And with time moving forward, those probes sent us the first ever images of the 4 giant planets of our solar system. Rovers roamed the surface of Mars for the first time, and mankind invented the first Earth-orbiting space station and the first giant telescope to see the universe beyond our Earth. In the early 21st century, astronomers discovered thousands of planets orbiting the stars, creating other solar systems, and more discovered the black holes. The universe is almost 14 billion years old, our solar system 4.6 billion years old, and our Earth 3.8 billion years old. In other words, universe has existed 56,000 times more than our species have. Our first few decades of exploring the solar system were merely a beginning, and in just 80 to 100 years from now on, our understanding of the universe and place in it will evolve in such ways that we today can only imagine. And folks, that's the conclusion to question, what is the universe?